Hello and welcome, friends, to a fun talk that we're going to have today as we start to talk about working with NaiveBayes classifiers in Python. So first, a quick backstory on NaiveBayes and how this all works, and then we'll just jump right into Google Colab and we'll write some code. So first thing I want to talk about really quickly is just NaiveBayes and how it all got started. Okay. So first of all, a few things about NaiveBayes. It's named after the English statistician Thomas Bayes. This is his picture right over here. A couple things that make it really interesting opposed to some of the things we've done recently. So one of them, for example, and we've just recently come off of k-nearest neighbors, is that you can only use categorical variables when you're working with NaiveBayes. So that makes things interesting. And what you'll have to do if you have numerical values is you'll have to get creative. Maybe you'll do some binning. Maybe you can do some conversion. There are ways to work around it, but natively, you're not going to A, just put words into it, and B, just give it straight up numbers, not just natively. That can cause trouble for you. So we'll talk a little bit about what to do with that. It is data driven, which of course we know. And the reason that we call it naive is that the predictors that we'll use, we assume that they're completely independent from each other. So the big picture, what do we do? So NaiveBayes or Bayes theorem is all about conditional probability. And the formula for conditional probability, right? So the probability of A given B, right? Something happens given something has already happened, is what you see here. So what you'll get with probability of A given B is the event occurring in the future based on the probabilities of things that have occurred in the past. So that's just sort of a ballpark idea. Of course, we spent an entire class period talking about it, but just in general, that's just a quick nuts and bolts thing. Now, I imagine you didn't come to watch this video for us to talk about the theory behind the mathematical calculations of conditional probability. What you really wanted to do was see how we were to code this. So what I'm going to do is just jump right over into Google Colab, and I think we just get out of it, or we just get into it. So let me just jump right in. We'll get out of this. And here we have Google Colab already. Okay, so now I've only done one thing in advance. So the first thing is we're working on this IBM employee data set. And I've already loaded that into a data frame using pandas. So if you're following along with me, if you're in class with me, then you're going to want to go to Canvas and grab that IBM employee data because that's what we're going to work with. Okay. So first thing I want to do is just kind of give you a ballpark of what we're working with. So if we look at the data, if we look at our IBM data, the whole thing is about employee attrition, employee churn, if you will. So what that's telling you is this person staying or is this person leaving? Like, did this person stay with the company? Did this person leave the company? Okay. And that's what you're seeing here going down with attrition. Yes, no, yes, no. That's what you're seeing. Okay, so good things about this data set that we like just as it is that a lot of the things that are being measured are already encoded in a way that we can just kind of feed them directly in to NaiveBayes. So things like total years working, we can do that. Well, no, we can't do total years working because that's a continuous value. But anything that would be one hot encoded, we could go through and do that. And actually, now that I'm looking at it, none of these are one hot encoded. So let's jump over a little bit to the left and make it a little bit more interesting. So here we've got some categorical variables that we care about, right? So we've got gender, marital status, education type, the department they work in, all of these different things. So we could use these things. So like we can use any of these categorical variables here, any of the categorical variables here, just as it is. We can do some basic label encoding, and then we can then use that as predictors for attrition. Okay. Now we can use age and we can use other numerical values, but we just have to get a little creative when we use it. So it's a little bit outside the scope of what I want to talk about today, but no, there are ways that you can make these things work depending on which algorithm you use. And I'll talk about that in just a minute, which one of the NaiveBayes models that you use between Gaussian and multinomial. But for now, I think we just jump in and maybe we do some code. And as we do our code, I'll just talk with you a little bit about as we go through. So we've already imported pandas, and that's kind of a basic thing, right? It seems like you need pandas for pretty much everything. So what we're going to need to do is pull in some additional libraries from Sklearn. And there's a couple different ways that you can do that. So first thing we're going to need, just kind of off the top of my head, is from Sklearn, we are going to need some pre-processing stuff. Okay, so let's go ahead and pull some of that in. So pre-processing wise, what are we going to need? We are going to need our one hot encoder. And off the top of my head for now, I think that's all we're going to need for now. In case I've missed something, we'll go back in and add it. So we've got our one hot encoder. So what other things are we going to need? Well, we are going to need our train test split. So that's going to be model selection. We are going to need our actual model. That would be pretty helpful, huh? NaiveBayes. And we're going to import. Now, this is where it gets interesting. So from NaiveBayes, there's actually a couple different flavors that you can choose here. There's a couple different model designs. So there's multinomial, okay? There's also Gaussian. And I'm going to import both of them, and we'll use both of them. We'll train on both of them, and you can see how which one performs better, right? So we'll go ahead and grab those two, and I'll talk a little bit more about them in a few. Okay. So the last thing we're going to need are some of our model metrics. So let's grab some of those. So we'll do sklearn metrics. We want to import accuracy, and I am a big fan of classification report. So that'll give us things like precision and F1 score and all that stuff. So feel pretty good about that. All right, we've imported that, step one. Now, we've also got our data frame that's already pulled in. So we don't need everything inside this data frame. Like, we don't need all of these things. So there's a couple different ways that we could go about this, splitting it down. And to try to make things easier, what I'm going to do is, let's see if we can't make ourselves a new data frame that just has the predictors that we want and the outcome that we want. So we'll start with that. So we'll just call this df1. And that is going to equal df. And let's just pull the columns that we want. So we'll go with gender. And we'll go with marital status. And we'll go with education field. I don't know if that F was capitalized. It was. That was good. We'll go with department. And we'll go with job role. Capital J, capital R. Shame on me. And last but not least, we'll need our actual outcome variable, and we'll even take business travel. Why not? We could always not use it later, but at least we'll have it in here if we need it. Then last but not least, we will need attrition, which is right there, attrition. So we're going to add that last thing in there. Excellent. So here's what we've done. So we've basically made a new frame that's sort of like a subset of our original data frame. So all this other stuff we're not going to use. I didn't want to confuse you with all that. So basically here's our new frame with just the things that we care about. So we will use all of these categorical things as predictors, and we will use attrition as our outcome or our target variable. So that's our good first step. So we're heading in the right direction. But what you're going to see is, as we kind of dig into this now, is that unfortunately, even though we do have categorical data, it is still just strings, right? It's words. And we know that in general, computers don't like words. Now, we still need it to be categorical, but we're going to need it to not be literally words. We need to translate this into something else, something numerical. So in order to do that, we are going to one-hot encode these fields. Now, depending on the nature of the data that you're working with, you may not have to one-hot encode. You may just be able to label encode. So what's the difference between label encoding and one-hot encoding? Well, label encoding would be if you've got multiple ordinal values. So think first class, second, or first place, second place, third place. you could replace first place, second place, third place with 1, 2, 3. And you can do that because it's ordinal, meaning that it is a ranked order set of things. But if you did that with nominal data, meaning non-ranked data, then your algorithm may very well think, like your program may think that, for example, if you did male is 1 and female is 2, it may think that male outranks female, for example. So we wouldn't want to do that. So what we would want to do instead is we would want to one-hot encode this data. So what one-hot encoding will do is it will replace male and female with a series of zeros and ones. But when it does, it's going to explode each one of these columns for each one of the variables that are inside each column. So if there's 2 different options inside the gender column here, it'll give you 2 columns, gender male and gender female. And then going down, there'll be a 0 if it is a negative value and a 1 if it is actually a male, for example. Okay, so that's a pretty easy thing to do. Now, inside Sklearn, there are a couple, well, inside Python, there are a couple different ways that you can one-hot encode. So you can use something in pandas called get dummies, but you've probably heard by now that it's not the most robust way of doing things. So there's a more robust way of doing it. Depending on what you're doing, you can get away with get dummies, but if not, Sklearn has a one-hot encoder, which is part of pre-processing. That one-hot encoder takes a little bit more time to work with. It's a little bit more time to work with, but it's kind of worth it. Like once you get into it, it's sort of worth your efforts in order to do that. So let's take a little bit of time, look at our one-hot encoder, and see what we can do with it. So the first thing I'm going to do is I'm just going to create a variable and assign our one-hot encoder to it. So I'm just going to go OHE equals one-hot encoder. And we need to do some things with this one-hot encoder. So first thing we're going to do is we are going to say sparse output equals true. So let's talk about what that is. So what that's going to do is that is going to give us a matrix when it comes out of here. Okay. And then we're also going to want to avoid our dummy trap. So what else we can do is we can drop our first variable. So that's going to help you avoid the dummy trap. So if you're not familiar with what a dummy trap is, it's basically like the curse of collinearity that happens when you dummy code something. And I can just very quickly show you what that means. So give me just a second here and we'll insert a line. We'll insert a little piece of code here. So let me show you what I mean. So just a quick example of collinearity and what that's going to do for you. So if I do, and we'll just cheat and we'll do get dummies because it's faster. So if I do pd.get dummies, and I want to get dummies from my df1 gender columns. We're going to go df1 gender, and I'm not going to drop the first. Okay, so I'm just going to leave it exactly as it is, and I'm just going to show you what this does. So when I do this, it gives me 2 columns now. So there's the female column, there's the male column, and each one is one-hot encoded. So 1 means that this person's a female, 0 means that person's not a female. So take a look. So just take your finger and put it over the male column. So just don't look at the male, just look at the female. So if I look at this and I see a 1 in the female column, I know that that's a female. And if I see a 0, it's not a female. Guess what? By default, it's a male. So really, both of these columns are telling you the same thing. So you really don't need them both. You've got 2 predictors telling you exactly the same thing. That's extra dimensionality you don't need. That's what we call multi-collinearity. We don't like that. Okay. So what you'd want to do to avoid this thing that we call the dummy trap is you would want to drop one of these because by default, you know what the other one is. So in both pandas and in the Sklearn one-hot encoder, there is indeed a way to drop a column or to drop a value without you having to go through and do it manually, right? So in pandas, there is a drop option. I think it's drop first equals true. That's how you would do it here. Okay. Now we're not using that in this particular exercise, but if you were using get dummies in order to encode this or to one-hot encode it, that's how you do it. And what we're doing down here with this one-hot encoder is exactly the same thing. We've said, hey, drop one of these columns. So now when I do this, that didn't actually do much for me yet, but it will. All we did was just create this instance. So the next thing we're going to do is we need to do something like x_dummy coded. Okay. So what we're going to do is we just create a variable, and we're going to then call our one hot encoder that we just created, and we're going to do a fit and transform. Now there's a couple of things about fit and transform. You can actually do these separately. So I could do fit on its own, or I could do fit and transform where I do them both at the same time. Now, because I've done this, oh, shame on me. I might have left a step off. I did leave a step out. So there is one other thing we'll need to do really quickly. So I don't need to dummy code my attrition column right here. I don't need to dummy code that. So if I feed it the entire data frame, it's going to dummy code everything in there. So what I'm going to need to do is I need to split these off. So we're going to insert another line. And really, I should have done that before I set the one hot encoder up, but it's okay. And what I'm going to do is I'm going to create predictors. And I'm just going to name off what I want my predictors to be really quickly. So my predictors are going to be gender, marital status, education field, department. There's a bunch of these. So give me a sec while I type these out. And actually, I should be able to, yep, I can. So I can just copy these really, really quickly. And we will paste these in. Now you shouldn't have to do this. If you actually just did this before I did, then that would be fine. But in this case, we just need to grab these in. So all I've done is I've created a variable, okay? And I've given it a list of column names that I want to be my predictors, okay? So the next thing I'm gonna do is I'm gonna say x, my value of x, equals, okay, df, which is my original data frame, actually df1, and I want to pull my predictors variable. Now, the cool thing about this, by doing it this way, is if you wanted to go back through and change this or change some of your predictors, all you need to do is delete one from the list, then go back in and run it again. Okay, so I'm saying my X is my df1 predictors, and my Y, in this particular case, we want to be df1 attrition, like so. Okay, good to go. Okay, now if you want to test that, if you just want to see it, no problem, we can do that. So if I just do X, there they are, right? So it's that data frame without the attrition. So now what I'm going to do is within this variable that I've created, I'm going to do a fit and transform for that X variable, like so. Now, when I do that, I'm not done. I want to send it to an array, like so. And let's see what we get. All right, so did we get it? Let's see. We did not, and that is because we need to wouldn't it help if I didn't type X twice? There it is. Perfect. All right. So there we have our actual array of data. So we need this, but we're not quite done yet, right? So we got it. Okay. So here's an array of all of our dummy coded data, right? So it's a series of ones and zeros. So now what we need to do is we need to get that series of ones and zeros into a data frame, right? So we're going to get that back into a data frame. So we're going to say is X dummy coded. And, you know, you're welcome to call the variables whatever you like. This is just what makes sense to me. So we're going to start with that. We've just created a variable. And from there, what we're going to do is we are going to use the data frame method. So we're going to go pd.dataframe. And we need to feed it some values. So the first thing we need to say is we need to feed it that X dummy coded data. So we're going to go X dummy coded. So there's my array. Okay. Now the next thing I need to do is tell it exactly what I want or where I want to get the column names from. Because if I just do this as is, which I can, so if I just do this as is and I look at X dummy coded df, it's going to give it to me. But when it gave it to me, notice there's no actual column label names. Okay. So there's actually something pretty cool that's built into the one hot encoder that can help you deal with this. Okay. So I'm going to go columns dot get, and it should be get names, get underscore, not get dummies. Oh, sorry. Let's go columns equals get. Nope. OHE dot get Did we not name our encoder? What did we name our encoder? We did name it OHE. Sure, so there should be a way to get names here. So give me just a sec here. OHE dot get underscore names. Bear with me, friends. Even the best of us sometimes have to think out loud for a second. So we're gonna go, we'll grab our encoder, and it should be, there it is, get feature names. Perfect. All right, let's try that. There it is. That's what we want. Perfect. All right, so take a look at what we did here. Now, we could make this better by renaming these. So it did go through and it pulled the feature names, but because we dropped one, see, so this is saying gender male and we don't have gender female because we know, for example, that first person is indeed female. Same with marital status, right? So it went through and it did marital status married, marital status single. There's actually a divorced in there as well. Okay, there's actually a divorced in there as well. So that makes things a little bit more interesting, but we know if you're not married and you're not single, then you got to be divorced. Okay, so we're gonna have one of those things in there. So that makes things a little bit more interesting as we go through and do this. Okay, so we've got all those in there. So at this point, we are ready, and we want to make sure we use our X dummy coded DF here to go through and do our train test split. Okay, so we're going to split this data up. Excuse me. Using our train test split. So how are we going to do that? Okay, how are we going to do that? And we also want to make sure that we use this particular data frame as we go through and do all of our stuff. So let's go through and set that up. Okay, so first thing I'm going to do is we're going to do our X train and X, and we'll call this val for validation, but it could be called X test. A lot of people do that. And we can do Y train and Y test equals, and we're going to grab our test train split, or excuse me, our train test split. Okay, so from there we need to feed it our X and we need to feed it our Y. So our X is actually our X dummy coded DF. Okay, and our Y is going to be just the regular old Y for attrition. But we're not quite done, so we need to tell it the 20%. So that's going to be our test size. And we needed to give it a random state. That random state can really be anything you like. Keep it simple, right? We'll call it 1. Let's run it, see what we get. Perfect. Now we're cooking. Okay, we're cooking with gas here, so things are looking pretty good. So next thing I'm going to do is I'm going to create the instance, or I'm going to create variables for our actual NaiveBayes class. So we're going to actually use this function or this model in just a second here. So what we're going to do is we'll do multinomial NaiveBayes to start off with, and we will say that that equals multinomial. I love for it to pop up because ever so often I forget the case of the whole thing. So like M is capital and the NB is capital. So I love to let Colab just sort of help me out here, and it makes life a little bit easier. So we'll do that, but we're also going to do Gaussian too. So we'll do GNB for Gaussian, and we'll say that that one is Gaussian NB, like so. All right, so now why did we do this? We did this because there's actually 3 different types of NaiveBayes calculations or models that you can create, and they give you slightly different answers, and it just sort of depends on the nature of the data that you're using and how that works for you to figure out what's best. In the instance that we are going to work with in class, the best thing for us to do, let's just create both, let's just fit both, and let's just see what happens. Okay, so this now is fairly easy, right? So we're going to go MNB, which we just created, and we're going to do dot fit. And when we fit it, we're going to fit it on our X train and our Y train. So it's going to be X train and our Y train, like so. We fit it, we should be all good. It's thinking. It's thinking. There we go. So we fit it. We can do the same thing for our Gaussian. So we'll see Gaussian, and we'll go Gaussian NB, and we'll fit that one on our X train and Y train. Now, ultimately, we're not going to run this one yet. So even though we have this code that we've put in, we'll do it on multinomial first, and we can go back and since we have the code in, we can go back and forth and sort of compare and contrast and see which one works a little bit better. So we fit on our multinomial data. So at this point, what we need to do is create our estimates. Okay. So what we'll do is we'll go y, and we can call this estimates. We can call it y predicted if you like, whatever that may be. So we'll do y estimates equals mnb dot predict, and we are going to predict our x validation data like so. Okay, so that should get us. And at this point, if we look at our estimates, we've got ourselves some predictions in there. Got a lot of no's, got some yeses. That's interesting. Okay, that's interesting. So the next thing we're going to do now that we've got these estimates is we're going to go through and we will do our metrics. So we'll see just how accurate this thing is going to be. Maybe it's accurate, maybe it's not that accurate. We can go through and tune some hyperparameters, maybe change out some of our variables and make that make a lot more sense to you. So for now, let's just keep it simple. So we'll do multinomial accuracy, and we will do that equals accuracy score. And we will take our y estimates and we will compare it to our actual y validation data, which we know the answers to. And it tells us, oh, did I spell something wrong? Is that a space in here? There is. Did I not call them y val? Oh, I called it y test. Ha 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 ha. So one sec here. We didn't call it y validation. We called this y test. Man, I am very popular today. So the one time today that I decided that I'm going to make a video, apparently I get 85,000 text messages. So, hey, stop texting me while I'm making this video. We're almost done. You hear this? It's ridiculous. All right, sorry about that. We'll put that to the side. So let's go ahead and print this. And we get an accuracy that's actually not that bad. Look at that. 80%, not terrible for this particular one. So we can go ahead and dig into this a little bit more. We can do a classification report. And we can do classification report like so. And for our classification report, we'll take our y estimates and our y test, and we can print our class report, and we'll take a look. So actually, it's not doing as well as we think. So this is one of those things that happens with model accuracy. So model accuracy is an interesting metric because it doesn't really do that much for your incorrect classifications. Like, it really rewards you quite a bit for your correct calculations. And what we see here is it is very much doing well on our no calculations, but it's not doing nearly as well on our yes calculation. So it's doing a good job at telling us no for attrition. But either way, hey, we've got something. We've gone through, we've done our basic first naive Bayes calculation. Now here's what we can do that's interesting. So we can go back through and we can create a second model right here. And that can be using the Gaussian. So it's a different algorithm. Takes somewhere in here. I need to go back through. Oh, sorry. Here we go. So we need to take this out. So we need to actually just do fit instead. So we're going to Gaussian. So we do GNB dot fit because I actually did that up earlier. And there we have that. All right. So then our estimates here, instead of being MNB, we can do GNB. We can do that again. There's our estimates. Okay. And we should be able to do a new accuracy. So we'll do this as GNB accuracy. Really about the same. And our class report. And you'll see, so this is actually pretty interesting. So the F1 score went up a little bit for our yes, went down a little bit for our no. I'd actually say that the Gaussian model is just a little bit stronger, even though the accuracy, if you see that, is exactly about the same. So either way, friends, hopefully this helped you out just a little bit. My phone went off about 15 times, so there's a good chance that I may go back and redo this a little bit later. So apologies for that. There's a lot of things going on, but I wanted to make sure that I got this out there so you guys could get started on a few things. And I look forward to talking to you guys soon. So hopefully this helped you out. I always am happy to answer any questions if you have anything along the way. Look forward to talking to you guys soon. Have a happy, safe day.